Greetings everyone, my name is Rick Storty, and I will be taking you through the presentation, which you will see, is results-centric, rather than involving lengthy mathematical derivations. Of course, for those members of the audience that may be interested, full and complete derivations can be found at our website in PDF format. We have quite a bit to get through, but we're going to cover 10 key areas. These are: 1. The Casimir force. What is it, and how is it generated? 2. The zero-point field. What is it, and how does it manifest? 3. The polarizable vacuum. What is it, and how does it relate to the zero-point field? 4. The polarizable vacuum model of gravity. What is it, how is it different to general relativity, and what can it do for us? 5. Electrogravity magnetics. What is it, and how can it be used? 6. The zero-point field frequency distribution. What is it, and what major problem does it cause in physics? 7. The zero-point field cannot contain infinite energy in flat space-time. This relates to the infinite energy in a vanishing volume problem. 8. Zero-point field frequency bandwidths. If the space-time manifold can't contain infinite energy in a vanishing volume, the associated zero-point field must be frequency limited within a bandwidth. What is it? 9. The extraterrestrial Casimir effect. If a Casimir experiment was conducted in an extraterrestrial environment, will a different force be measured? 10. Extraterrestrial predictions. If the Casimir force varies, depending upon the local gravitational environment, what will it be in specific situations? The central theme running through this presentation is that the Casimir force is historically derived, represents an average cosmological quantity, because of the manner in which it was formulated, but I'll discuss this in the coming slides. The Casimir force is literally a force from nothing. It arises when two parallel, neutrally charged, reflective metallic surfaces are in close proximity. In such a configuration, virtual particles emerging from the zero-point field induce a pressure differential across the system, resulting in the environment doing work upon the plates to push them together. Although the Casimir force is commonly described as an attractive force, it is not literally a force of attraction. Rather, it is a physical manifestation of the field pressure differential acting across the system per unit area, pushing the plates together. In other words, the environment does work upon the system in search of a new equilibrium state due to the absence of virtual particle pairs emerging from the zero-point field between the plates. An important aspect of the Casimir force equation shown here is the manner in which it was derived. The equation shown was derived based upon a number of important assumptions, one being infinite projected plates stemming from infinite length and breadth, another being that the temperature of the plates is 0 Kelvin. The reason these assumptions are important comes from their impact upon the physical problem they're describing. In my view, the only conceivable physical interpretation of these key assumptions would be a set of plates running parallel through the center of the observable universe, from one end to the other, somehow missing all the matter such that no matter exists within the cavity. For such an analogy, the Casimir forces derived can only be representative of an average cosmological quantity. Consequently, my expectation is that the Casimir force should deviate from the cosmological average when a parallel plate experiment is conducted in a curved space-time manifold, for instance at the surface of a planetary body. Given that the Casimir force is dependent upon the constitution of the zero-point field, we will discuss the zero-point field in greater detail. Possibly the best way to describe the zero-point field is to describe the processes that are attributed to its constitution. In this slide we can see that virtual particle pairs spontaneously emerged from the space-time vacuum, momentarily popping into existence before either annihilating each other, or spontaneously disappearing back into the zero-point field of their own accord. We can also describe each of these virtual particles as a wave function, depicted as a family of random wave functions as shown. The spectrum of possible zero-point field frequencies is given by the equation stated. However, a significant and substantial problem exists, that is there is no upper limit to the frequency spectrum. This means that as the wave function frequency of a virtual particle approaches infinity, the energy contained in the dimensions of its wavelength also approaches infinity. This literally means that a vanishing volume of space-time may potentially contain an infinite amount of energy. This might also mean that, should a virtual particle pair of sufficient frequency emerge from the zero-point field into normal space-time and stay there, the universe could collapse in on itself, because that point of space-time would be energetically equivalent to an infinite number of supermassive black holes. So clearly, a problem exists with the model. To stop the wheels of logic grinding to a halt, the customary approach is to spray some WD-40 on the problem in the form of renormalization, in order to run the machine smoothly, and ensure that the mechanism is lubricated. However, the issue with that approach is that the renormalization process involves the subtraction of two infinite quantities, which quite frankly, is nothing more than a trick, because the subtraction of infinity from infinity, mathematically speaking, equals anything new like. In other words, renormalization is a non-physical correction sprayed over a physical process. To my way of thinking, this is an unacceptable solution to a physically problematic model. The solution to the dilemma I feel, is embedded in understanding how matter affects the zero-point field in terms of vacuum polarization. To fix the infinite energy in a vanishing volume problem properly, we need to understand the effect of the presence of matter upon the zero-point field. As this representation depicts, the presence of matter polarizes the zero-point field, such that the zero-point field may be described as a polarizable vacuum, that is the zero-point field plus matter equals a polarized zero-point field, and a polarizable zero-point field is the polarizable vacuum. If the polarizable vacuum involves a material overlay upon the zero-point field, from this illustration, the obvious question becomes, what is the polarizable vacuum model of gravity? The polarizable vacuum model of gravity is an optical analog to general relativity. It describes gravity as a phenomenon arising from a change in energy density in the gravitational acceleration field surrounding an object, acting like a lens. No invisible grid lines or fabric, just the effects of light passing through a lens. For instance, in the case of gravitational microlensing, incoming light from a source star is bent around an intermediary object by the change in the refractive index of the space-time surrounding it. This yields an identical observation to general relativity, but without the need for the unverifiable claim of space-time curvature. Within the polarizable vacuum model of gravity, the how and why mechanism for light bending around an object is clearly explicable, as opposed to the physically questionable concept of space-time curvature under general relativity. This is not to say that general relativity is wrong. The message here is that in my view, general relativity is an inferior construct to the polarizable vacuum model of gravity. However, general relativity is a mature and well-accepted doctrine, but so was a flat Earth once upon a time too. Notably, Schwarzschild and Reisner-Nordstrom solutions exist for the polarizable vacuum model of gravity, but at the very least, it can be conservatively stated that the polarizable vacuum model of gravity is isomorphic to general relativity in the weak field. Thus far, we have talked about the zero-point field, its relationship to a polarizable vacuum, and how the two concepts relate to gravitational acceleration. To tie these together with electromagnetism, we shall introduce the concept of electrogravimagnetics. Electrogravimagnetics 1. Is a natural progression from the polarizable vacuum model of gravity. 2. Pertains to the equilibrium between matter and the space-time surrounding it. 3. Functions as a methodology bridging the electromagnetic and gravitational gap. It executes these three key things, by describing the polarizable vacuum at any point in a gravitational acceleration field as the summation of a Fourier series comprised of electromagnetic wave functions, and equating this summation to the expected spectral energy density distribution of the zero-point field. Once this is done, we obtain the equilibrium conditions associated with the zero-point field and the material object under consideration, for instance the zero-point field equilibrium radius of fundamental particles, planets, galactic structures etc. The equation shown demonstrates the energetic equality between the mass energy density per unit volume of an object, and the spectral energy density distribution of the zero-point field when integrated over the frequency domain. The frequency distribution stated here is the distribution derived by H, Rueda and Puthoff in their quantum vacuum inertia hypothesis, which explains the origins of inertia. However, even this distribution faces the same problem of infinite energy in a vanishing volume as the slide I put up earlier. So how can we overcome this problem? In terms of zero-point field spectral limits, what is the zero-point field frequency distribution? The zero-point field spectral limits may be computed by solving for them via the EGM methodology, where the polarizable vacuum is mathematically described as cubic in form, but specifically obeys a Fourier series distribution. By doing so, we are able to demonstrate that zero-point field spectral limits vary depending upon the physical situation under consideration, as depicted in this graph. Most significantly in this diagrammatic representation, the lower limit of the zero-point field is 0 Hz, whilst the upper spectral limit is bounded by the Planck frequency. Consequently, the zero-point field is prevented from ever accommodating a virtual particle of infinite frequency. Therefore, we insist that the infinite energy in a vanishing volume problem is solved under the EGM construct, because a vanishing volume can never contain any more energy than the mass energy of the local gravitational point source. So how do we mathematically demonstrate that the zero-point field cannot contain infinite energy in flat space-time? Let's look at an example of what happens to the spectral limits of the gravitational acceleration field, in terms of quantum mechanics and zero-point field theory, in the case of a solitary neutrally charged, non-rotating point mass at rest, occupying an otherwise empty and flat universe. As the distance from the point mass increases, the value of the refractive index approaches unity. Thus, the lower spectral limit approaches zero as the radial displacement approaches infinity. Consequently, the upper spectral limit approaches the lower limit and the spectral bandwidth converges to zero. Therefore, the spectral energy density of flat space-time approaches zero and the cosmological problem of infinite energy is avoided. Hence, a vanishing volume at infinite radial displacement contains no zero-point field energy. Thus far, we have demonstrated that the spectral limits of the zero-point field depend upon the radial displacement from a gravitational point source. Moreover, we have shown that the zero-point field cannot contain infinite energy within a vanishing volume, or in flat space-time geometry. From the previous slide stating the expressions for the minimum and maximum zero-point field spectral limits, we are able to represent these graphically above, emphasizing that the zero-point field cannot accommodate a wave function of infinite frequency. All the locations depicted in this graph exhibit finite spectral characteristics, such that the zero-point field simply does not exist at that point in space, either side of the limits indicated. In most cases, the zero-point field bandwidth extends from the millihertz to yottahertz range, and for either side of those limits the zero-point field does not exist. This does not mean that it is a field of zero values, it literally means that it does not exist. Therefore, Heisenberg's uncertainty principle is not applicable outside those extremities. The vertical axis represents the available zero-point field pressure to act on the parallel plates. This is a very easy quantity to approximate, and is computed from the change in mass energy density across the plate cavity. You can also see that a decrease in Casimir force is predicted with a decrease in polarizable vacuum field pressure. Note that I did not say zero-point field pressure, I used the terminology of polarizable vacuum field pressure. I have done this quite deliberately, because the zero-point field in the presence of matter is no longer at its ground state, it has been polarized, and consequently termed a polarizable vacuum field. You'll see more about changes in the Casimir force in the coming slides. In the previous slide, we established that the zero-point field spectral limits vary depending upon the ambient gravitational environment, specifically the available energy density of the gravitational acceleration field surrounding a material object. We graphically compared the available zero-point field pressure to do work upon a set of parallel plates for the Moon, the Earth, Venus and various terrestrial orbits. The graphic shown here is an extension of that theme, demonstrating that for the case of the Earth, our expectation is for the Casimir force to decrease with respect to altitude. Hence, the application of a parallel plate configuration Casimir experiment is anticipated to yield a diminishing Casimir force as altitude moves from low Earth orbit to mid-Earth orbit to high Earth orbit. The dominating reason for this being the decrease in energy density of the polarized vacuum across the dimensions of the parallel plate cavity as altitude changes. Our next task is to accurately predict the change in Casimir pressure across the system, in order to make extraterrestrial predictions. I suppose the obvious question in everyone's mind at this point is, what is the equation? Well, here it is on the screen. You can see how it was derived in the conference proceedings, but in summary, it has three key components. The first component being the left-hand side of the equation, which represents the Casimir pressure for a parallel plate configuration experiment. The next component being the delta function on the right-hand side, which represents the change in energy density of the gravitational acceleration field surrounding a material object. The third component being the remainder of the right-hand side, which represents the field modes of the polarized vacuum, that is the zero-point field, which sum together and scale a delta contribution. So, what are we predicting precisely? We are predicting that on the surface of the Moon, a parallel plate configuration experiment will yield an increased Casimir force of 37% relative to the surface of the Earth. On Mars it will be plus 12%, and remain approximately the same on the surface of Venus as it is here on Earth. Notably, we are predicting that the Casimir force will gradually diminish as orbital altitude increases, decreasing by 95% by the time we reach high Earth orbit, relative to an experiment conducted at the surface of the Earth. Why is this so? The reason this behavior mathematically occurs is because the delta function governs the hierarchy of the list shown. The delta function is a standard physical function, and is simply the rest mass energy of an object, divided by the volume of a sphere of radius r. The actual numerical values are governed by the yellow circled component of the equation. This is what EGM brings to the table, in order to make the predictions shown, and takes into account the influence of the spectral frequency modes within the zero-point field over the Casimir cavity. This seems interesting, but so what? Application of the EGM photon radiation method to the Casimir effect suggests that the experimentally verified neutrally charged parallel plate configuration force may differ within extraterrestrial gravitational environments from the gravitationally independent formulation by Casimir. Consequently, the derivation presented herein implies that a gravitationally dependent Casimir effect may become an important design factor in nanotechnology for extraterrestrial applications. This means that, by considering the ambient gravitational environment with respect to the zero-point field and the Casimir effect, potential catastrophic failures of nanotechnology applications in terrestrial orbits may be avoided or circumvented, and the financial risk associated with equipment failures in such remote locations may be mitigated. I hope you've enjoyed the show. Please feel free to talk with me after the presentation, or you can contact me by email or phone.